Hi, me again. Welcome back. I just uploaded my latest video. There it is on the studentification of City of Pietermaritzburg using Google Earth Engine. And everything we can learn from Google Earth in terms of the studentification. Now, it's not the only method or option, but it's indeed a very important option simply because of the ability to do subnational or granular level analysis. So I just uploaded it. Have a look at it. Please like and subscribe, share. Let's grow the channel together. Thank you very much. You're the best audience I can have. Okay, so something very different. I'm dabbling a little bit on different topics just to see where I can find some new areas to grow the channel. I know that not everybody uses or knows about Earth Engine, so I want to expand a little bit on my horizons and work a bit on different topics. Now, as some of you may know, I'm also an economist, and part of my duties or part of the work that I do is I lecture at the university and in economics. So I thought, let me expand my channel into the economics field and see what that yields. Not that I'm going to forget about Google Earth Engine and leave all the remote sensing stuff because that's the primary focus. But yeah, something different. Maybe, who knows? I might hit the jackpot at some point. But let's try all avenues and see what happens. So I've got an honors class in microeconomics, and one of the the topics within the honors microeconomics is general equilibrium. So this will be set of videos that specifically deals with general equilibrium and specifically on the Edgeworth Box diagram and so forth and so forth. Okay, so let's give it a try and see where it goes, where this leads us. So the Edgeworth general equilibrium, Edgeworth Box diagram. Just want to check this. Yeah, so please mind the spelling. I'm not going to check all the spelling the whole time so just for that, let me just put it nicely in the middle, and there we go. So general equilibrium. What is general equilibrium? What does it refer to? Okay, so let's first dissect the word general equilibrium. Now, as you know, if you've done economics at first year level, first year undergrad level, what we typically call introduction to economics or principles of economics or microeconomics, or what we call at my university economics 114, meaning economics first year, first semester, 4 credits, or full semester. Then we deal with demand and supply. Okay, so let me just get my pens quickly. And this is also another pain, so please bear with me. So let's use start blue. So in economics 114 or microeconomics, we deal with demand and supply. So that's the supply curve. That's your demand curve. That is quantity. That is prices. That is zero. And the point where the demand and supply curve intersect is what we call equilibrium price and equilibrium quantity. Okay. So that equilibrium price plus my equilibrium quantity, that is for a specific product or service. Let's say Coke. Okay, so let's say Coke. So that's the supply and demand in the market for Coke, or in the Coke market. Demand for Cokes and the supply of Cokes within the coke market, and where demand and supply intersect, or when demand and supply is equal, we talk about equilibrium. Okay, and specifically we talk about partial. It's difficult to write with this pen, so just bear with me. Partial equilibrium. Okay, so that's what we deal partial. We don't normally talk about it as partial equilibrium, but in reality, that's what we call partial equilibrium. Now, we know that there's a coke market. We know there's a market for chips. We know there's a market for chicken. We know there's a market for salt. We know there's a market for haircuts, etc., etc. And all these markets interact on a daily basis. They all interact on a daily basis because they all work within an economy. Okay, and so what happens in the coke market will have an influence on the chip market, and what happens on the chip market has an influence on the chicken market, and so what happens on the chicken market has an influence on the salt market. What happens on the salt market has an influence on the haircut market. So these different markets, so in this case, the number of markets is equal to 1, 2, 3, 4, 5. There's 5 markets. So these markets continuously interact with one another. They're not standalone, isolated markets. They are markets within one system. So as I said, if the market for coke maneuvers, so for example, there's either increase in demand for coke or there's a decrease in supply of coke or whatever the case might be, that influences the equilibrium price and quantity in the coke market. And that changes in the equilibrium price and quantity market in coke, then influences the equilibrium price and quantity in the chips market. And the change in the equilibrium price and quantity in the chips market then influences the equilibrium price and quantity in the chicken market. And what happens in the chicken market then influences what happens. So you'll have a situation where there's equilibrium in all 5 markets. Then something happens in one market. That market adjusts to that shock or that change. And that adjustment then influences all the other markets, until you get to a new steady state where all 5 markets are in equilibrium. So when all 5 markets are in equilibrium, that point is what we call general equilibrium. So general equilibrium is a point where all your markets are in their individual equilibrium. So in this case, general equilibrium is equal to 5 partial equilibriums. Okay. So general equilibrium, so in this case, general equilibrium is equal to 5 partial equilibriums. Okay, so general equilibrium in this case is equal to 5 partial equilibriums. Now, we know that those partial equilibriums are only there for a minute period, not for long periods like months, quarters, years, etc., etc. The demand and supply fundamentals for coke changes rapidly. So that general equilibrium may only exist for a few seconds. It may exist for an hour or two. It even may exist for a day or two. But I doubt that it's going to last for longer than that, because people's demand and supply activities changes continuously. So you may sit outside and the price of chicken feed, maize, for example, would be estimated at X amount of units per kilogram. And next moment, there's quite a lot of rain or a hailstorm devastates half of the maize fields. Immediately, there will be an increase or a shortage in supply, and the price will increase. Look at the oil price, continuous change. Look at your currency, continuous change. Look at the market for fresh produce. Every day there's demand and supply activity happen at the fresh produce market, etc., etc. So prices, although you and I might perceive it to be fairly stable, changes very, very frequently. And the change in price either influences the quantity, demand, and supply, or the quantity, demand, and quantity supply influence the price, vice versa. And as I said, because of the system mentality or the idea that all these markets are within a system, it makes sense that what happens in one market will influence other markets, and you have those ripple effects, etc., etc. So general equilibrium is a theoretical concept that basically relates to the individual markets or the partial equilibriums within that system. And you can just imagine the number of partial equilibriums. If you go into any supermarket, let's call it Pick and Pay or Macro or Game or wherever your supermarket is, think about the number of products there are in that shop. And so for each and every single product, there is demand and supply. And so when there's demand and supply for each and every product, there's a partial equilibrium. So that could be millions and millions and millions of partial equilibriums. Now, as I said, it's one partial equilibrium to another. I mean, it doesn't have to go one to one to one. It happens simultaneously, etc., etc. So, yeah, general equilibrium, therefore, talks to all these individual markets being in equilibrium at exactly the same time. And I said that's most probably a rarity, to say the least. So that is general equilibrium in a nutshell. Okay. Now, how do we present general equilibrium? We know how we present partial equilibrium. We present partial equilibrium by our standard demand and supply curves. So partial equilibrium we present fairly straightforward by our individual or by our demand and supply curve, with the supply curve gets shift, demand curve gets shift, there's movement off the curve, there's movement on the curves, etc. I'm not going to go for all those details. You should be familiar with that. So that's the representation of partial equilibrium, our normal demand and supply curves. However, we don't represent general equilibrium in the same way. We rather present general equilibrium using the Edgeworth Box diagram. Okay, using the Edgeworth Box diagram. Okay, so just remember, partial equilibrium presented by our standard demand and supply curves. General equilibrium presented by our Edgeworth Box diagram. Okay. Let's save there and let's continue to the next one. So what is our basic assumptions? Okay. So remember we said here's 5 products and services. Now, to visually present this in any meaningful way, we have to make certain assumptions. We cannot present our general equilibrium using all 5 products. That's working not, yeah. So what we want to do is we want to work in a 2-dimensional way because we can visually understand it. If we have 3 or more, then we cannot present it in a 2-dimensional way, and therefore it becomes a little bit more complex. So we make certain assumptions. So one of those assumptions, when we deal with general equilibrium, is that we only have 2 products or 2 services. Only 2 products. Let's call it products. Okay. Now, when I talk about products, it could be services included. So let's say I like my Coke. I drink Coke a lot. I like Coke. Okay, so one of those products are Coke. What would be the next product? Think about something. Could be a complement, could be a substitute, could be an inferior good, it could be a service. Let's go haircut. I do haircuts every second week. I've got short hair, so I do haircuts. Sorry, spelling is not that great, but you get the idea. So we reduce the number of products or services available, or we assume that there's only 2 products and services available. And the reason why that is for simplicity, nothing else. These 2 products represents millions and millions and millions of products. Okay, so we have these 2. Okay, we further assume that there's only 2 individuals. Call it households, call it individuals, doesn't matter. And let's call them Mr. A and Mrs. B. Okay. So with our assumption of 2 products or 2 goods and services, we only also assume 2 individuals or 2 households or 2 businesses or 2 countries. Whatever, 2 entities, whatever those entities may be. Okay, so we assume that. We further assume that these 2 entities, okay, that we further assume that these 2 entities, let's call it they sit on these 2 islands. Okay, they each have an initial endowment of these 2 products. So person A will have an initial endowment of Coke and hair, CNH. And person B will have an initial endowment of Coke and hair cuts. Okay, so they each sit on their little island. Call it their house or their camping spot or their trailer or their boat or their plane or wherever they are. They're each sitting there. Now, whether they obviously know of one another, they can see one another, they may be familiar with one another, they may not be familiar with one another, but they know they're there. So each person knows they're not alone. They know of the other person. Okay? They also know, obviously, their own endowment, and they know the other person's endowment. Okay? So person A, for example, has 6 Cokes and have 2 haircuts. Person B may have 8 Cokes and 12 haircuts. No, don't, because then it's going to be exactly equal. Let's make that. I need to be careful to undo, because sometimes the whole thing just goes off. So let's say 14. Okay, so that's not 12, that's 14. Okay, so person B has much more of both. It has more Cokes and it's got more haircuts than person A, which have 6 Cokes and 2 haircuts. Now person A knows person B's initial endowment, and person B knows person A initial endowment. So they know each other's endowment of Cokes and haircuts. Okay? I said they know of one another. They are familiar with one another. We further assume that there's no spare stuff. There's no hidden treasure somewhere with extra cokes and haircuts. There's no third person with coke or haircuts. We assume that the sum of the two are the full amount of these two products. So therefore, person A's endowment of these two items or these two goods and products plus Mr. B's endowment is equal to the total endowment. So therefore, for C, we have Mr. A endowment of plus Mr. B's endowment of C, which is equal to 6 plus 8 equals to 14. So there's 14 cokes. Mr. A has 6 of the 14 and Mrs. B has 8 of the 14s. Similar with the total amount of haircuts is person A's amount of haircuts plus person's B amount of haircuts, which in this case is 2 plus 14 is equal to 16. Okay. Now you can express this as fractions or percentages and all of these sort of things, but the nuts and bolts are exactly the same. And that is that Mr. A has 6 cokes and Mr. A has 2 haircuts. Mrs. B has 8 cokes and 14 haircuts. The sum of the haircuts in the economy is the sum of these two, which is 14. And the sum of haircuts in the economy is the sum of those two individuals, which is 16. So as I said, the 14 and 16 is total demand and supply. Total demand and supply. Meaning each of those markets are in partial equilibrium. Okay? Because they are sitting there. So Mr. A's got their endowment, person B's got their endowment. They're not trading, they're just sitting with their stuff. So they have got partial equilibrium between demand and supply of each, etc., etc. Okay. Hope that makes sense. So, cokes is equal to 14 and haircuts is equal to 16. So demand and supply for cokes 14, demand and supply for haircuts is equal to 16. So Mr. A can either supply more cokes, and if Mr. A supply cokes, okay, let's go here. So let's just draw it again. So there you've got Mr. A, he's got cokes and he's got haircuts. Then you've got Mrs. B that has cokes and haircuts. So Mr. A can supply, for example, cokes, and in return, oops, now let me just quickly see, I don't want to move this. Okay. And in return, if he supplies cokes, then Mr. B supply haircuts. Because he won't supply coke to demand coke. He will supply coke to demand haircuts. And if he supplies haircuts, he will demand coke. So in this scenario, Mr. C supply cokes and demand haircuts. In this case, Mr. B demand haircuts and demand coke and supply haircuts. In that specific scenario, could be opposite. So let's go for it again. In this case, Mr. C will supply cokes Okay, he supplies the Cokes to Mr. B, and in demand, he wants haircuts. I supply Cokes to demand haircuts. And if I supply Coke, then the other person demands Coke. Because I will only supply Coke if he demands Coke. And if he demands Coke, I will supply Coke. And opposite. If I supply Coke, I demand haircuts. If I demand haircuts, he will supply haircuts, and vice versa. Okay, so I hope that makes sense. So that dynamics influences the relative prices of Coke and haircuts. So there will be a price for Coke, and there will be a price for haircuts. And this dynamic, which I just explained here, this dynamic that I just explained here, that will influence the relative prices for Coke and haircuts. Okay. So the less Coke I want to supply, and the more Coke he demands, the higher the price for Coke. The more Coke I want to supply, and the less Coke he demands, the price of Coke will fall. So within this, we need to find out the relative strength, call it, of demand and supply, because that will influences the price of Coke. If the supply is more than demand, the prices of those things will fall. If the demand is more than the supply, then the prices will increase. So normal demand and supply arrangements, okay, normal supply and demand arrangements. But it all depends on the strength of the supply and demand. If the supply of Cokes, meaning I'm trying to get as many of Cokes as possible, and he actually doesn't want 2 Cokes, then I have to decrease the price or incentivize him to take my Cokes, and vice versa. That will mean the price of Cokes will decrease, and vice versa. So that's important, and we'll get to that a little bit later. Okay. So all this interaction has a change in price, and that obviously influences the partial equilibrium, and therefore general equilibrium analysis. Okay. So we can present all this that we've put out here. All of this we can present as an Edgeworth box diagram. Okay. So let's start with the Edgeworth box diagram. As I said, it's a box, and there's my box. Okay, square, normal square, 4 sides, length, width. As I said, 2-dimensional. And that's now why you can see why we reduce our goods and services to 2 and reduce our households to 2. Otherwise, you won't be able to use it in this 2-dimensional way. So we're going to plot either Mr. A on this side, and Mrs. B on this side, or Mrs. B on this side, or Mrs. A on this side. It doesn't really matter. So let's go person A here and person B there. So Mr. A works this direction, and Mrs. B works that direction. Okay. So that's the first important thing, because B is an inverse of A. And if we take our normal demand and supply graph, then we have a y-axis and we have an x-axis. And so this is 0, and therefore that becomes greater. This is 0, therefore that becomes greater. And therefore, remember, what is the objective of a household? Is to consume more and more and more. Remember, the objective of a household is to maximize utility. So person A wants to maximize his utility. But the same for Mrs. B. Mr. B also wants to maximize her utility. And remember, that is 0. So her x sits there and her y sits there. So for her to increase her utility, she will go from right to left and from top to bottom. Because the 2 is a mirror, like an envelope, okay, like a normal envelope. So another assumption that we now make is that both A and B wants to maximize his or her utility. If we drop that assumption, case closed, go home, nothing further to see. It's all done. Nothing further to see. Okay? If we assume that they are happy, they're content, let's say, how do I say that? Let's say they are nuns or priests or monks, which we assume are not materialistic like most of us are. Okay? Then that assumption from maximizing utility is obviously not valid, and they're happy whether they have one piece of bread or two. They don't mind. They just don't care. But for most of us, we're driven materialistically. Our happiness, our status, call it that way, whatever, is very much linked to what we have. And therefore, the more we have, supposedly the happier you are and all of these sort of things. But the bottom line is we assume that individuals or households want to maximize their utility. And that implies you want more. You want to satisfy your happiness. If you satisfy the next one. So our third assumption is that we are driven by utility and we want to maximize our utility. That means A wants more of both X and Y, and B want more X and Y. A moves from bottom left corner upward to the top right corner, and B moves from the top right corner down to the bottom left corner. Okay. Now, as I said, because there is only a finite amount of haircuts and Coke, they cannot consume more than what they are available. So there has to be some sort of trade. Okay, coming back to this particular diagram. Okay, so that in a nutshell is how the Edgeworth box diagram operates. It's a square. It can be what's your vierkant. Could be a rectangle, it could be a square, doesn't matter as long as it's got 4 sides. Bottom left is person 1, top right is person B. They are inverse from one another, so they're exactly the same, just inverse. They both want to maximize their utility, so A wants more of Y and X, and B also want more of Y and X. Okay, but at some point, if they have an initial endowment, if they want to change it, they have to trade. If they're happy with the initial endowment, then there's no need for trade. If A is happy with what he or she has, in this case he has, then it doesn't matter whether B is happy or not, A is not going to trade. And if A doesn't trade, then B doesn't trade. So if B is happy with what she has, doesn't matter whether A is happy or not, B is not going to trade, therefore there will be trade. Or if both of them are happy with the initial endowment, they're not going to trade. They'll only trade if both of them think they can be better off. So if A thinks by trading he's going to be better off, and B thinks that by trading she's going to be better off, then there's incentive for them to trade. So then both of them will trade. And they hopefully would be better off. So if you go into a shop and there's things there and you buy them because you think you're going to be better off. But if you go into the shop and you don't buy anything, then you don't think you're going to be better off by buying something. Okay. It happens very regularly. You go into a shop and you walk out empty. You didn't buy anything simply because you didn't think you're going to be better off. There's alternatives. You think you're going to be better off by doing something else with your scarce resources. Okay, but in this case, they will only trade, and that's important. They will only trade if they think, they individually think they're going to be better off. So meaning both think they're going to be better off. That's the only condition they will trade. They won't trade if they think they're going to be worse off. They don't think, they're not going to trade if they're happy, etc., etc. Okay, so that's very important to understand as well. And so this will be the basis for our general equilibrium analysis. Okay, and obviously we are assuming that the initial endowment is substandard, or they're not happy with the initial endowments. They each got an island, and this is what is on the island, and they both say, well, I'm happy, I'm alive, I'm happy I have these things, but I can be better. I can be better. It can be better. Let's see if I can trade A to B, B to A. Okay, so this is the basis of our general equilibrium analysis, and I said we use the Edgeworth Box diagram to basically present or to discuss our general equilibrium. Okay, so let's quickly, before I conclude this specific video, and we'll do the next one. Don't want to go too long on each video. Let's cut it down. So we've got person A, we've got person B, and let's say person A, Coke is here, and haircuts are here. Could be opposite, doesn't? Yeah, could be opposite. And person B's haircut is here, and its Coke is there. Let me just save it. And so this thing has a habit of closing in the worst moments. And then you forget it, so I must keep reminding. Okay. So person B, as I said, will go this way. More haircuts, more Cokes. Person C will go this way. More haircuts are Cokes, and more haircuts, so he will move this way. So given the initial endowment, let's go back to the initial endowment. The initial endowment is that C has 6 Cokes, and therefore Mrs. B has 8 Cokes. And that gives us, okay, so let's then do person A has 2 haircuts, and therefore person B will have 14 haircuts. 2 and 14. So that implies that they lie somewhere here. Right? It's just, oops, forget, that's always safe. That they will lie somewhere here. So that's 6, that's 2, that's 8, and that is 14. That point there. That point there. Okay. So in this case, A's got 2 haircuts and 6 Cokes, and B, Mrs. B, have 8 Cokes and 14 haircuts. So that gives us the total Cokes equal to 14, and total haircuts is equal to 16. 2 plus 14, let's see. 2 plus 14 and 8 plus 6. So there's our numbers. So that represents the initial position. That represents the initial position of the two. Now, as I said, they will stay there. They will stay there if they're both happy. Or if one of them are happy. They don't both have to be happy. Only one has to be happy. Because if I'm happy, why must then doesn't matter if you are happy or not. It's irrelevant. I'm happy, so I'm not going to do anything. As I said, they will only trade if both of them want to trade. If both of them think they're going to be in a better position. Okay? That's the only time they will trade. If each individual think they will be better off. Okay? One or both of them think they're happy or are happy. You're not going to think you're happy. You're going to be happy. Then there's no trade. And that initial endowment stay. Then that's general equilibrium. And that implies partial equilibrium in each market. Meaning demand and supply for Coke, demand and supply for haircuts. All problem, no problem, all done, dusted. They go on their merry way, they're happy. There's no changes. Okay, it's only when there's going to be trade there's going to be a change in demand and supply, which will influence the relative prices and quantities of each of those two goods and services. Okay, so I hope that makes sense up to now. I hope that makes sense. So in our next video, we're going to continue on our analysis on general equilibrium using our Edgeworth Box diagram. Okay, so I'm going slowly, but I hope this makes sense and I hope you can follow. If you want me to spend a bit more time on any of these parts or sections, then just leave it in the comments and I'll happily come back to you. But yeah, so far, this is just background. To our next video, we're going to continue on our general equilibrium analysis using the Edgeworth Box diagram with this initial situation with person A, person B, and the two products and the initial allocation. Okay, so we'll continue with that in video 2. Okay, so with that said, I'll see you on the other side.